Consider the following figure. We have three semicircles, where the smaller two are tangent to each other and are inside the largest semicircle. If the radius of the semicircles inside are 6 and 4 units, what is the length of the diameter of the largest semicircle? Let's connect the centers of the two semicircles by a line segment. Since the radius are 6 units and 4 units, the length of the drawn segment is 6 plus 4, which is 10. We have formed a right triangle as shown, where in the hypotenuse is 10 and the shorter leg is 6, which is just the radius of the inverted semicircle. Let A be the measure of the unknown leg. We will apply the Pythagorean theorem to solve for A. We have A squared plus 6 squared is equal to 10 squared. 6 squared is 36, while 10 squared is 100. Transpose 36 to the other side. We get A squared equals 100 minus 36. 100 minus 36 is 64. Take the square root of both sides, therefore A is equal to 8. Now, the radius of the inverted semicircle is 6 units. It can be observed that the two radius can form a square with side lengths of 6 units. Next, let's add together 6 plus 8 plus 4, which is 18. And then let's draw the following line segments as shown. Recall that whenever a triangle is inscribed in a circle, if one side is also the diameter of the circle, then the triangle is a right triangle. The diameter is the hypotenuse, and the angle opposite is a right angle, so this must be a right angle. Assume this distance is n. According to the Geometric Mean Altitude Theorem, the length of altitude to the hypotenuse is the geometric mean of the lengths of the segments of the hypotenuse. Following the same ratio and proportion to our problem, we get n over 6 is equal to 6 over 18. Multiply both sides by 6. On the left side expression, 6 divided by 6 cancels out. On the right side, 6 divided by 6 is 1, and 18 divided by 6 is 3. And then 6 divided by 3 is 2. So, we get n equals 2. Finally, to solve for the diameter's length, just add 2 plus 18. Therefore, the diameter is 20 units. Thanks for watching. Please subscribe to my channel for more engaging math puzzles.